Assalamualaikum and hi everyone. My name is Nurul Ain binti Sari and today I'll be presenting the overview of our project. Firstly, what is resistance welding? Resistance welding is a widely used process where heat is generated by passing an electrical current through the materials to be joined. This heat, caused by electrical resistance at the contact points, melts the materials and allows them to fuse together. It's commonly used in manufacturing for joining metals quickly and efficiently. On the other hand, what is projection welding? Projection welding is a specific type of resistance welding where rest projection or localized features are created on the surface of the workpieces. These projections focus the welding current at specific points, which concentrates the heat, allowing for a controlled and precise weld. Some of the applications are widely used in industries such as automotive manufacturing, electronics, and construction for tasks like welding sheet metal, joining electrical terminals, and fastening components.
So we move into the working principle of resistant welding. The first point is the heat is generated by passing an electric current through the contact point of two workpieces. The workpieces then place between flat electrodes which apply pressure. When current flows, the projections heat up rapidly, melt, and collapse under the force, forming a strong weld nugget. After cooling, the joint solidifies, creating a durable bond, and this method is highly efficient for mass production as it allows multiple widths in a single operation while minimizing heat distortion. In a simple words, the resistant welding joins metal by using electrical resistance to generate heat and pressure, causing the materials to melt and fuse together. Thank you.
Okay, for the type of projection, which is we have some of types, which is here you can see first round dimples and second one elongated ridges, circular or elongated corner of the walnuts and domes type. So we can see here also have a lot of like walnuts that have like specific which is round dimples or dome types. So it depends on application itself, and then like if it is very easy for the resistant welding to use this type of the projection. All right, for the welding cycle, they have like around five cycle, which is for the first one, we need to insert the parts between the electrodes. So for number second, the electrodes will become closer to the part, and then the force will apply. And then for number three, after the force apply and the electrodes become close to the parts, the current will turns on. And then what happens when current turns on? So the current will go through the electrode through the parts. So we can see at that picture, which is number three, it will mold the metal inside the part, so it will stick together inside. So after that, uh, the current will turn off, and then the electrodes, we open the electrodes and force like unapplied. So we also can see here at the graph over there, you can see the graph like from number one to number two, the force is inclined. So inclined at the same way for the current one, and then until the number 4 to 5, the current will go down because we turn off the current. So after that, that's how the part will start with this uh welding.
Moving to the next part, which is the application of projection welding. Projection welding is essential in automotive manufacturing for assembling body panels, chassis, and electrical components. It delivers strong, distortion-free welds ideal for high-precision parts. For example, in car body panels, it is used to join roof, doors, and side panels with minimal distortion and high strength. In electrical components, it ensures reliable connections for terminals, connectors, and relays, especially with thin materials like copper and aluminum. Its efficiency and consistent quality makes it ideal for high volume automotive productions. Secondly, in electrical and electronic parts, projection welding is widely used to join small precision components needing strong electrical conductivity. For examples, in connectors and terminals, it ensures durable corrosion resistance joints critical for device reliability. Or on other components like it is ideal for sensors, switches, and parts made from thin materials, providing clean and precise welds with minimal heat damage. And lastly, projection welding is used in manufacturing industry. Projection welding is used to weld mechanical parts such as fasteners, bushing, and brackets. In fasteners, it joins nuts, bolts, and rivets securely, resisting mechanical stress and vibration. On the other hand, in bushing and bearings, it provides strong, precise welds for moving components that endure frictions and pressure.
Projection welding offers several advantages that make it highly effective in various industrial applications. Here are the four keys for benefits. First one is the precision. Projection welding allows for precise control of the weld location. Since the welds are formed at predetermined point, it ensures consistency and accuracy, which is especially important when welding small components or assemble with tight tolerance. For the next one is the productivity. This process is highly productivity because it enables multiple welds to be made simultaneously in a single operation. This is not only save the time but also improve manufacturing efficiency, especially in mass production environment. For the next one is projection welding can reduce heat input. And how? Unlike other welding methods, projection welding concentrate heat only at specific point where projections are made. This reduces the overall heat input into the material, which helps to minimize distortion and preserve the mechanical properties of workpiece. And lastly, for the fourth example is projection welding can reduce welding current because the projections localize the welding current to small areas. Less current is required to produce a strong weld. This makes the process more energy efficient and reduce wear and tear on the welding equipment. In summary, projection welding is valued for its precision, speed, and efficiency, making it preferred choice in many automated manufacturing process. That's all from me. Thank you.